Hi guys, you're welcome to my YouTube channel. Today I'll be showing you how you can design a reinforced concrete structure that is made of flat slab. But majorly there are three types of flat slab. We have a flat slab with column capital, or what you can call column head. We have a flat slab with a slab dropping panel, and we can have the combination of the dropping panel and the column capital. Okay, but for today I'll be making a video of a flat slab which the supporting column will be having a column capital. Then for the next class we'll be making more videos on the rest. So let's begin. You can go to the orthogonal axis generator right here. Now just drop it anywhere here. Okay, so let me use the default axis, and then I will just click on OK. Alright, then I will go to this story menu. Then I will insert story. I can just insert let me insert two stories. Okay, then yes, and then you can go to edit story. Okay, I will leave this as 3 meter, this as 3 meter. I'll just change the description. I'll write this as ground floor, and then here I'll write first floor. This has nothing to do with the design, if you put it there or not. It is just a description. I will leave the foundation as it is, then I'll click on OK. Alright, then you go back to the ground floor. So the first thing I will do is I will insert the columns. Okay, so I will go to the column tab here, so click on column. Then for the column, the dimension of the column, let me use a circular column. Let me use a circular column, like this circular column, not this one. This one is a hollow circular. So I'll use a circular column, and then the dimension, I can change the dimension here. Let me use the dimension of 300, then OK. Okay, you can see the dimension has changed. So even you can come here to change the dimension, so it doesn't matter whether you change it there or you change it here. Okay, so before I insert it, I'll come to the drop here. This is where you can insert the column capital. Okay, so you click on this you are seeing that insert column drop panel. That is actually the column capital. Okay, so you click that, and mind you, my dimension is 300, so that means my column capital should be wider than 300. Okay, so let me assume that my column capital is 400 by 400. Okay, 400 by 400, so that will be like 50. Is that not even small? Let me use 500 by 500. Okay, so that will be like 100 at all sides. Okay, so here just click center, so that it will be 250 at this side. Okay, click on center, it will put it at the center. And then the height of the dropping panel, let me use 350. That is how much it will drop. Okay, so and at every point here I need the column here, so I'll just drag throughout. Okay, so then you close. So if you zoom in, you see your circular column and then your drop panel. Okay, so you can see that the diameter of the column is 300. Okay, so that is that. So the section of the column, that depends on you. Okay, so right now all I just need to do is to insert the slab. Okay, but if I insert the slab now, the slab will, let me insert one slab and show you. If I insert one slab and then I just place it here, okay, you will see that the slab will be sitting from the center of the column up to this point. Okay, so all the remaining part of the column will still be outside, and you can see the drop panel will still be outside. So I don't want stuff like that, so I want the slab to completely sit on the column capital. Okay, so I will just delete this slab, hit delete on your button. So to do that, I will offset this boundary axis. So right click and then click on offset, then you can drag your mouse upward, then on your keyboard click on F2, then you can change the dimension. So I'll offset off upward by 250. Okay, all right, so that would be on this same line with that. I believe you know why that is 250. Okay, then I'll offset to this side, then F2, then to this side, that's negative, that will be negative 250, then enter. Okay, you can escape. Then at this side I will right click, offset to this side, just drag your mouse to that side, then this is positive 250, enter. Okay, then at this side I will offset downward. Drag your mouse downward. You don't even need to drag it downward. It will, in as much you know the negative and the positive side. Okay, so 215. All right, so that is good. So now I just need to insert the slab. Okay, so to do that, you come to slab, and then the dimension of the thickness of the slab, I'll use a slab. Let me use a slab of 150 mm. Okay, and then the cover, let me use 25 mm, and then I'll go to the load. So under the load, remember a flat slab does not have beam. Okay, so under the load, the value, I'll use a flat roof. Okay, then the imposed load, I will just use maybe any commercial, like parking lot. Okay, this one, which is parking for cars. In parking lots we use flat slab a lot, so I'll use this one, which is parking for cars. Okay, and then the reference level should be in 0. Okay, so I will have to use this insertion point, which is peak axis. Okay, so I'll click this axis, then this other axis, and then this other axis, this axis, and then the first axis. What I just did now is that I picked all the axes that is going to be the boundary for the slab. Okay, so I picked it as they are perpendicular to each other. Okay, so I will delete all of this, then I will start again by picking this one, then this one, this one, this one, and the first one. Okay, so you delete axis and you continue. Pick this, 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 and then this. Okay, so that is done. You can mirror, but it won't take me anything to just draw it one by one. This, and this. Okay, and this one, this one, this one, and then this one. Okay, now delete the axis. I'll use this one, this, and this. Okay, so I'll pick this, this, and this. Okay, so you delete, and then one, you pick this, you pick this, and then this. Okay, this, and then close this. 1, 2, 3, 4, and the last, which is the first one, then that's all. Okay, so now I have all my slabs intact. Okay, so I have the slab and then I have the column. Let's say in 3D, come to view, and then you right click to see this, so you can see how it looks like. Okay, so you can see that the slab is actually sitting throughout the capital. Okay, so this is how I want it. Alright, so what I just need to do now is I need to repeat the same thing for the other story. So I will just need to come to the story menu, and then you go to generate story, and then I'll generate everything to this other story. Then you click on OK, then yes. Okay, so the process has been completed. Then you close. So if you check your 3D now, you will see that we have the same thing at the top and the same thing at the bottom. Okay, so just the same way, there is no beam at all. Okay, so after we are done with all this, what we just need to do is we need to analyze. Okay, we need to analyze, and then we design. But before I analyze, I can just draw the strip for the slab. Okay, so I want need to come back and start modeling after the analysis. Okay, so let me draw the strip. I'll be using FE strip. Okay, so click the strip, and then you go to the FE strip, and then you can pick this one, which is the last one. Okay, so then you come to the general tab. Then automatically, what you should know that the FE strip, we actually use an extension of 1000 mm at the right and for the left. Okay, so whatever you draw, let me try to draw this one. Hold your control so that I can be straight. Sorry, this is for y-axis. Let me draw for the y-axis. So draw. You can draw the x-axis first. depends. Okay, so you see that what I've drawn here actually is just 1000 meter span. So this is the discretization part of the FE analysis. You only do for 1000, but you can actually decide to extend this. Let me try to extend this to 26. Okay, and then this also to 26. Okay, then click on update. You see that it will span up to the kind of so even better still, you can just draw one span. You can just draw one like this at the center. Okay, and then you draw it to the bottom. So instead of drawing another one here, you can just expand this one so that it can span up to this side, expand this side so that it can span up to this side. Okay, so instead of drawing multiple strips. Okay, but I would like to use the 1000, so I'll change this one to 1000. I'll change this one to 1000 again. Okay, then update. Okay, so I only have that small part, so I'll do the same thing for this side, and then I will drop it here. Okay, so for this one, so let me put it here, and then not just outside to outside. Okay, so this, we'll drop it here, and then this, I'll drop it here. Okay, so that is good. Okay, so I will do the same thing for the other story, which is story 2. So go to floor, second none, then draw the strip, and then this is for X, right? So I'll draw for the X. Okay, I'll draw for this side, and then I'll draw for this side. Okay, then for the Y, just hold the control so I can be straight. Okay, so I can close that, and then now we just need to analyze. So to do that, you go to the analysis tab. We have to do the building analysis for the columns, and then we do the FE analysis for the slab. Obviously you can see we use FE strip. Okay, so I go to building analysis. Okay, and then you go to the loading combination. This is there already. If this is not there, you just need to click on loading generator. Okay, and then you click on OK, so this will generate. Okay, and then you can go to OK. Then I'll go to edit material. This column I'll use 25/30, and then the rebar, let me unselect everything, and then I'll use 16, and then 20, then OK. I only have concrete column, so that's all, and then OK. Right, so you can go to the analysis tab, and then you click for the column, so it will analyze the column and design the column immediately. So start. Okay, and then that's all, so you click on OK. Okay, so we can go to the post analysis to see the column design. Okay, so we can see that all of the column passed. Okay, and then you can see the utilization ratio, none of it is greater than 1. That is fine. And then you can see the reinforcement, we have 6y16. This one we have 6y20, 6y16. So it is basically 6y16 and 6y20 depending on the location. Okay, and then you can see the spacing of the link. You have everything is y8, and then the spacing we have some of 175, we have some of 225, we have some of okay, I think it's just 175 and 225. Okay, so that is good enough. Then you can close that. So the column have been designed. We just need to do the slab design. Okay, so to do that, you go to the analysis tab again, then you go to FE floor analysis. So you go to that. So I prefer to use the batch FE chase down, so I will do for batch FE, since that we do the 2 stories at the same time. Okay, so if that is the case, make sure this is in story 2, because just make sure it is in the last story. Okay, so if that's the case, you have to click this one so that I can include the column section in the FE model analysis, and then click on this one too. Okay, I don't want to use the sparse solver, so I won't click it. So you go to batch FE chase down. Okay, so this one you can leave it, and then this is just the element shell size, the size of the shell. You can put it, you can even put it in 100. Okay, and then the mesh uniformity, I'll leave it at this. Then I want to include the column in the FE analysis. You have to click that. All right, then the slab stiffness, I can change it to 0.5. Let me change it to 0. Let me even change it to 0.25 so that I can make it more stiffer. You know, when you reduce this stiffness factor, that we make it more stiffer. Okay, so the beam factor, I don't even have beam, you can leave it, and then the column, just put it in 1.0. Okay, so if that is done, and make sure this is clicked. Okay, so just click on OK and then click on continue. So this will analyze the two of the of the of the stories at the same time. Okay, so the analysis has been completed, we just need to transfer the model. Okay, so you click on OK. To do that, make sure you're on post analysis tab. Okay, then you go to the analysis post processing, and then this is story 1. Okay, you can see this is story 1, right? So then make sure this is in story, just we are going to do for everything, but you have to know the story you've done for. So this is story 1, right? So you click on analysis post processing. Okay, so you can draw your slab strips so that you can have this in 2D, and then you can just check all of your steel to just see everything. This is everything. Just close. When you close it, to transfer the model. The purpose of coming here is to transfer the model, which is this. Okay, so if that is done, just click on OK. So transferring of the model is essential. That is why you have to come to the post analysis tab. Okay. Okay, so that has been completed. So what you need to do, you have to merge the column result. This is very essential. Click on the merge column result. I don't have beam, so this is not essential. You can just leave this. Okay, so the purpose of merging the column result is that you did two different analyses. You have an analysis which is PD analysis for the column, and we have the FE strip for the slab. So you have to merge the two analyses so that the load from the upper slab will get distributed to the column, and the load from the upper column can get distributed to the slab downward. Okay, and then the slab can get distributed to the column. So just to have that kind of interaction, you have to select this. All right, so we are done with the story 1. We have to go to story 2 so that we can transfer the result, transfer the strip. So you go to post analysis again, and then click on this, and then click on this so that we can repeat the same thing. All right. Okay, so you can draw your slip, you can pick a contour, any contour, no, just standard contour. And then, but let me just close it for sake of time, I'm not checking. So, and then start transferring the strip. Okay, so that is done, and then you can see the merge column option is there, so you can just close. So now that you are done, all you just need to do is you right click, and then you go to arrange steel bars, then you click on update steel bars. Okay, and then you see that okay, yeah, this has been reinforced. You can see the reinforcement here. Okay, notice that the reinforcement will only span from where we draw the strip up to. You can see the strip is from here to here. Okay, so let me show you. You will see that the span of the reinforcement, you can see it is just from here to here. All right, so that is the purpose of the extension of the strip. Okay, all right, so we've done that for this side. Let's go to the other side, which is story 1. Okay, so you right click, and then you go to arrange steel bars, then update. Okay, and then you can see the reinforcement here. All right, so that is all for that. So, and then one more thing you can check for is you go to the concrete design, and then you come to the column punching check, this one, so that you can check the punching. So you have to select this one so that you can check the drop panel. You have to select this one too, then you click on design. So this will check your column punching area. Okay, so when it is done, it will bring a report, then we can see the report. Okay, so here is the report. You just need to wait for some moments for it to load the report on its own. So you just have to come here. You see that okay, your punching shear is less than the VC. Okay, so you see that okay, yeah, this is adequate. Okay, so for the other column, which is, you can see for story 1 again, but this is the column 2, you come here, you can see adequate. That's good. You come for story 3, which is, you can see 1C3, you come here, you see okay, adequate. All right, so that is how you check for your punching. Why am I checking for punching? I need to check for punching because this is flat slab. A flat slab usually have the problem of punching because you want to confirm if the column is not punching the slab, because obviously the slab will be sitting directly on the column without no beams. Okay, so the column can easily punch the slab, so you have to confirm if there is no punching or there will be a punching. Okay, so let's close that. So and when you zoom in, you will see the punching. Okay, so if you can see, this is the red portion, which is your punching. You see that the red punching is within the green. That is telling you that okay, your punching is still within the allowable perimeter. Okay, all right, so that is how you go about that. So this is all for the column capital flat slab. I have to make more videos on flat slab where we have to use the dropping panel, and then there will be one more where we will combine the dropping panel and the column capital. So watch out for the videos, and if you like my content, make sure you give this video a like, and then you need to subscribe to my YouTube channel. Thanks for watching.